So now going more and more into analyze phase, we saw a pair and also the F test. Now we're going to dig into talking about the different kind of root cause analysis that we can have, right? So we know the analyze is all about understanding root causes and proving that those root causes exist. Now there is kind of this table help us to find out what are the best tools to use, right? So I kind of already talked about this because we already started with scatter plots and t-tests and some hypothesis testing and f-test and all that. Basically, we're always thinking about y and x variables, right? So we have a y variable, which is the performance metric that we want to improve. And we have x variables that are things that we can change, and we want to see the result of those changes into y to see how to improve y, right? So x and y, sorry about that, can be an attribute or continuous variable. So what we need to look at here, is to understand, what kind of x variable and y variable we have. So here is a very, very important slide for you guys to understand what method to use. So my independent variable and my dependent variable, my y and my x, if it's continuous x variable and continuous y variables, I can use scatter plots, correlations, and regression models. Okay, and we're going to look at a regression model. We talked about scatter plots. We talked about correlation, right? Both are continuous variable. When my x is continuous, but my y is an attribute, means that I have something that is in a measure scale that's impacting something that's an attribute. I'm going to use logistics regression. And when I have, and we're going to talk about that, when I have x variable as an attribute, and my y variable is a continuous, then I'm going to use t-test ANOVA or MANOVA. Means that being a certain group impact something continuous, right? Something that is on a scale, right? And which is the t-test we did, and the confidence interval, we can use that as well. And if they're both attributes, I can use chi-square test, which also we're going to take a look at that. Okay, so I know very exciting things coming up. First, we're going to take a look at regression. Regression is kind of a normal understanding after you do scatter plots, right? You have two continuous variables. You're trying to understand what is the impact of one thing, another one, and that's when you use regression analysis. And basically, you're trying to predict, right? What is the change in x variables? How does that going to impact an y variable? I have x as independence variables, and I have y as dependent because they depend on the value of x, right? So you guys already had some regression, right, modeling before. I'm going to review that. If you have any questions, we can take a look at it in class. But maybe, you have to plan how to collect data, of course, analyze, refine the model, and validate it, right? And we're going to kind of touch on these two ones. What is a regression model, right? This is a simple regression model, right? And you have something that's called mx plus b or something that I learned, that you guys learn in middle school or high school. I think it is mx plus b, which may be good or maybe more, even make more confusion, right? So the simple regression here is y equal a plus bx plus e, and e is just the error. So a is the constant, and b is going to be the slope. Okay. So I'm just waiting a little bit, see if things are better at home, but you can still hear some screams and shouting at the noise in the background. That's okay. They're good. They're alive. They're getting older. We're keeping it healthy. So the multiple regression model is this one where we have multiple b's, multiple slopes, and also I have multiple. I only have multiple slopes because I have multiple x variables, right? So you can have different variables impacting in y. I still have a constant there, right? but I will have multiple X variables. So this is an example. We're going to take a look here, a producer of glass fiber that would like to know the relationship between 3 process variables and breaking strength. So the process variable are the X variables. I have 3, and I have 1 Y variable, which is the breaking strength. This is how the data is presented to us. We have 25 observations, and we have to collect these 3 or 4 data points from each observation. The bake time, the reagent purity, the pull speed, and the breaking strength, right? We collected the data from 25 different batches, right? So the first thing is to plot. That's usually the first thing you have to do, put in a scatter plot, right? So we have breaking strength as Y here, here, and here, right? So if you look at this, again, 2 continuous variables, does it seem that bake time impact on breaking strength? Is that a positive correlation, a negative, a strong or weak? So you can see that, you know, we can have a line here in the middle, right? And there is a linear relationship between them, and it is a positive relationship. So I'm increasing this bake time, and I'm also increasing bake strength. I can see that happening here. Of course, the line's not going to be perfect, because other things are going on at the same time. If you take a look at reagent purity, try to do it 3 times. Reagent. Can you guys see an impact? Kind of weird, right? You can see going up, but then you go up again. So if you put a line here in the middle, you don't see much relationship. It's going to be all over the place. And pull speed, you may see something here because it's going up here, it's going down here. So there's something going on, but it's not as strength as bake time, right? So the scatter plot are kind of present some idea of some things that are going on, right? And again, I told you about scatter plots. It's good to do them so you see if the relationship is linear or is not linear or is exponential or something else. So we have here the way to do that. You click regression on data analysis. You have to present Excel. To do in Excel, you have to present the 3 columns of X variables, one and next to each other, because you have to select all of them together. So you select the Y variable here. You select the X variables here, labels if they're labels, confidence interval that you want. And then it will show you something like this, right? So here we're going to talk about R and R square, right? So two very kind of important elements of regression. And again, this is just a review. If you have questions, we can go more in depth. But I'm just going to assume that you guys remember regression for your stats class, and 395 we go through regression as well. So what is R? If I'm looking at just one variable, if it's 1x and 1y, R is actually the correlation. So it's going to tell you if it's a positive or negative, go from -1 to 1. Adjusted R square is the percentage of the Y variable that I can explain by the X variables. So that's basically the percentage of the model that is good, the percentage of good things that we're doing with the model. So, and that goes from 0% to 100%, right? From 0 to 1. So this is a pretty good model with the adjusted R square of 82%. The ones that we only find in practice examples, never in the real world. By the way, I use a lot of regression model in research papers. So here is the ANOVA here, which is basically saying if it's significant, means that our regression is significant. So if the significance of F is less than 0.05, means that we actually created a model that is significant. And here is the information that we want. So it's going to tell us our coefficient, which will mean the beta, right? The beta value. So first for the intercept, which is our constant, right? Our first alpha there. And if it is the p-value to say if it's significant or not. Again, we're going to use the same p-value of 0.05 to say if that variable is significant or not. And then we have the 3 variables that we're testing, right? Bake time, purity, and pole speed. The same thing, the coefficient, so the number that goes before the x1, x2, x3, x4. The p-value here. So which ones are significant? Well, intercept is significant. Bake time is significant. Purity, yeah, purity is better. It's not significant. What does that mean? It means that the beta there could be 0. And if it could be 0, that beta means that it's not good enough for our model. And because of that p-value being higher than 0.05, we're going to exclude this. But it's actually not 0.05. So here we're going to use a rule called BONNA-FERRONI rule to exclude when you have like multiple values there, multiple p-values that we're looking at the same time. And I know that you might have that in a different way in other classes, but for this one, I have to teach you like that because that's the way that they use for the Greenbelt exam and in capstone projects. Okay, so I have to teach you like that you have to take the p-value, which is the 0.5, and divide it by the number of variables that you are testing at the same time. So here we were testing 4 variables. So we divided by 4. Our critical value now is 0.125. So it's not the 0.5 that I need to look at the p-value, is the p-value of 0.125. Again, only do that for this course. Don't do that for other courses. And I'm only teaching like that because that's the way that other faculty member create the Lean Six Sigma Greenbelt exam. Okay, so in this way we have two of the x variables that are still on our model. Then we need to run it again because now we're going to run only with those 2. So we exclude that one that the p-value was higher than 0.012, and we run it again. All of them are within the threshold. It is significant, and that's our final model, right? Adjusted R-squared is super high. Super good for us. We're very, 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 very happy. So let's use this. This is our model. So, and then we can write it down. Another thing that's good to do to see the correlation between our x variables, right? So one thing that is an assumption in a regression model is that x variables don't correlate to each other. It means that they're not going the same way. If they're correlating each other, maybe I can take one out because one is already telling me the impact of that x variable into the y variable. So one assumption is they don't correlate. So you have to see if you don't break that assumption. So here what we're doing is to, because if they correlate, means it could be because there's an impact of one variable in the other variable. So your model should be different. Our correlation here, so we did a simple correlation scatter plot here, and then you can test the correlation in data analysis toolpack as well. And there's very slow, right? Very, very small. So correlation could be from -1 to 1, and here we have a 0.14. Okay, so this is our model. The 20.489, remember, came from here. The 0.158 came from here, and the 0.158 or 0.4808 came from this, right? And we have P and we have the T here. Remember some expectations here. We can only say that this works for the range of values of P and T that we tested, right? It's not, you know, oh, just go forever and put the, you know, bake time, it's gonna be great forever. It doesn't matter what bake time it is. No. If you increase too much, maybe you're going to break everything, right? It's only for the values that you're collecting data for. It's also good to do some residual analysis after that. So again, this is just a scatter plot of the residual. So when you click there on Excel, you can click to put the residuals. The residuals are the errors, right? The difference between the predicted value, which is here, right? This table, predicted value, and the actual results for that y variable. Okay, so one minus the other are the residuals. So basically, how far off you were, okay, from the actual getting the right answer. And we do this, and Excel kind of present this table for you, so you don't need to do anything. You need to create the scatter plot, which tells you if there's something going on or not. So if all the data, you know, in are negative on one side or all positive in one side, if you can see something weird there, it's because maybe there's another variable that you didn't collect data. So it could be a good or it could be a bad thing. So what I want you guys to do now is go to that practice Excel example. So let's share the Excel file. And you have here the regression model. So all the examples that I just talked about, you know, all the scatter plots are here. The regression, the residuals, the correlation, and blah, blah, blah are all here. The second one that we run without one of the X variables. What I want you guys to do is do this problem here. So that's an example actually coming from a capstone project where we collected data. Of course, we changed a little bit of data. About labels and literature that a company that produces appliances we did a project with, Electrolux, and we're trying to predict the unit price based on dimension of the label, number of colors of the label, volume, and if there is a description or not. Okay, so you have 1, 2, 3, 4 variables, X variables, and you have one Y variable, which is unit price. So I want you guys to do all those, go through all those steps in a regression model, build the scatter plots, run, do the correlation, you know, find out if you exclude one, and run it again, and do the residuals, okay? And I'm just gonna go over in class. I'm not going to give you time to do that. So you have to do it right now. It's on the data analysis. Oops, I did it again. Data analysis 2-pack. We have regression here, right? So you have to fill this, and you have the residuals here. We didn't talk too much about, but that's how you do it. Okay? Are we good? Feel confidence? I know that you guys can do it. I know. So go ahead and do it.